So a while ago, this part was posted on the forum as a challenge to convert this from a imported SolidWorks file into a aluminum or a Alibre sheet metal part. And studying this part for a bit, it's not as easy as you would probably think, but it is possible to convert this into a part that could be made by what's called bump forming. And bump forming converts a large radius or large curve part, sheet metal part, into a series of multiple bends at lesser angles to approximate the curve with a series of short bend flanges, and the part ends up looking similar to this. So typically what happens is you start in the middle, bumping each one of these bends the required number of degrees until you get half done, and then you turn around and do the other half, and at the end you have your formed part. What this allows you to do is, on one of these short flat segments, is to add these flanges, because Alibre requires straight flanges to add, or straight sections to add flanges to. On SolidWorks allows you to create a large curve and then add a flange on that curve. So it enhances their sheet metal capability quite a bit. But anyway, in Alibre, going from a nice smooth curve to a bump formed part like this, depending on the length of these flanges or distance between bends, is how smooth this curve is going to be. So the steps in getting from a curve to this bump form part are going to be fairly long, so I'll try to hustle along as best I can. So let me close this part down. I'll get back into my sheet metal part, turn on some reference planes, and I'll go through the steps that I would use in converting this to a bump form sheet metal part in Alibre. So the first thing I'm going to do is I'm going to start a sketch on this ZX plane, and I'm going to create a reference arc here, and I'll just grab this and draw it out, and then I'm going to add a coloradial constraint to this so that we align it to the curve of this part. And then we're going to also constrain this on the ends. So let me swing this around and I'll get this end point constrained. Get this up on this end there, and the same on this other end. Okay. Now that gives me an arc that I can measure, and that tells me that my radius is 516. Let me get this oriented here. So we're at 516 millimeters, and now we need to figure out what the total angle is. So another reference lines. Go from this end to the origin and to that end, and our angle that we measure here is 151.96. So we're not on solid or whole numbers here, so we can round that to 152. We also need to know what the angle is between these mounting holes and what radius we're going to need to locate those on the appropriate tabs. So in order to figure that out, we need to get some reference geometry around these hex holes. So in order for that, I'm going to take and just draw reference circles around each one, and I'll get the circles in place, and then we'll constrain them to the hex hole. And we're going to use a coincident constraint at 3 locations here, and I want to get up to this node. Okay, wait a minute here. Okay, where's my tools? Selection filters, solid. I need vertices here. Okay, now we can go to work. And now we got a coincident from here to this point, to there, and from here to there. Okay. Now we go to the next one. We'll do the same thing on each one of these cutouts to get the circle constrained on the hex hole. And one more. Okay, now we can get a reference line, and we're going to go from this center of that hole to the origin, and then back to this one, and from this one to the origin, and to this hole. Okay, now what do we have here? Between these two holes in the middle, we have 28 degrees, and on the outside ones we have 153. Getting my view set up here. Okay, so now are these centered on the part? And if we take a look here, we can see that we're not quite centered, but we're going to treat these as being equal on each side here, just for the sake of this example. I'm assuming there's going to be some leeway and some clearance on the mounting holes that this thing attaches to, so that allows a little bit of leeway with the mounting hole locations. The other thing we need to know is what's the length of the radius of the mounting holes is 505 millimeters. And let's see here, what else do I need to know? Because I'm going to lay out some line segments here to act as our formed part. And where do I start that? Typically I would start in the middle and work my way around, but I need to make sure that I cover these short flanges with a segment long enough to include that hole. So what I'm going to do now is I'm just going to start in the middle with a solid line, and start drawing off these segments. And we'll just place a few in here. And get the right one up here on the end. Okay, now here's the fun part. We're going to start putting equal constraints on all of these, so that just select them one at a time as you go around. And there we go. Okay, now let's see what we have here. we're going to have a straight segment right here, and what's the length of that going to be? We're at 56, 57 millimeters on that, and it lines up over here. I think we're going to want to add a couple of more in here, get those a little bit shorter. So I'm going to delete this one, and I'm going to grab this node and I'm just going to push it down, and we're down to 52 over here. Come down a little bit more. Okay, we're at 37, and we've got a straight segment here that's approximately centered on that hole. So let's finish off with some more line segments, and we'll try to get the lengths at about, what did I say, that was 37.2. so I'll just kind of draw out here about 37. Try to get them around 37 or so, and finish off and fill in the end here. And I'll do two short ones here. Okay, now we'll come back here and we'll add our equal constraints. So we'll pick up this one, and we'll just add all the rest of these. Okay, now what do we have here? We have a short segment here that's approximately on that hole, and we have a short segment here that, and we're going to be offside a little bit, I think, but we can account for that, I think, by getting rid of this last equal. Let's add a dimension here. Actually, first, yeah, let's see, let's make this 30, and then we'll come back with some equal constraints in here again, because we lost all of them. Okay, now our segments look like they're 36 approximately there, and this one on the end is 30. Let me shorten this up to 25, and it goes to 36 on the rest of them. Okay, and I just want to make sure that I have a straight segment that is approximately centered on these mounting holes. Okay, that looks good there. Now, what we can do is mirror all these sketch lines to the other side, or we can go ahead and draw another bunch of segments over on this side the same way. And so what I'm going to do is I'll just draw segments in here. And these are going to be approximately 36 or so. So I'll just kind of watch my readout on the length of each one. here what I'm going to do is I'm going to add a dimension on this last one right now. Get this aligned to the line there, and come back and we'll add some constraints on this side, and we'll make them all the same size, equal to this other side. And what do we have here? 45. That's 36. And this one over here was 25. Let's see what we got here. So now this side is a lot shorter. Let's take this down to 15. And where's... Okay, we've got a tab here that we can use, and we have a tab here that's a little bit longer, but I think we can get the idea here. So now we've got our sketch in here. Go to contour flange. No, we can't. We have to get our sketch over into sheet metal. So what we're going to do now is do a select all, Control A, select all. Under the edit menu, come up here, copy with base point. And now we're going to be prompt to select our base point. So we go up and we're going to select our origin. And as you get your mouse over the origin, you'll see the little origins point sign pop up there just below the highlighted lines. Go ahead and select that base. Now in a new sheet metal part, we're going to have a thickness of 1.5 millimeters to match what our part is. And we're going to grab our ZX plane. We're going to activate a sketch, right mouse click and select paste stamper, and we have our sketch. And we want to pick our origin. There we go. Now I want to add some dimensions back in here. Grab our dimension stick here. No. Dimension, where's our arc? There we go. 5/16, and orient to plane, and then we'll just add our dimensions back in. Oop, one fell off. Okay, I think that'll help for right now, for demo anyway. We're going to go ahead and go to sheet metal, extrude, wait for the contour flange to build all of its flanges. And what we need here is a length of 60 millimeters. So we're going to extrude this 60. And there's our part so far. Okay. Now we have that much done. Now we come back to our part here. Let me get out of this sketch mode, or so, we got to get a sketch on this 1, 2, 3, 4th tab on each side. 1, 2, 3, 4. Okay. So on the 4th tab, 1, 2, 3, 4, we're going to be adding a flange. So 1, 2, 3, 4. And we're going to make this 20 millimeters long, total length. We're going to form it inside. And we need a bend relief in here. So we go to bend relief, we'll have square, rectangular, and our width is going to be 1. Depth is going to be 3. And go back to our main tab, and we're going to offset each end by 1 to allow for our bend relief to get put in here. And now we can go ahead and select our remaining tabs, or flanges. There's 1, 2, 3, 4. And then on these ends, we're going to be on the one, have one short on one on the end. And okay. So now we have our flanges done. Click apply and close. Okay, now as a test here, let's see what happens in our flat pattern. Bingo, we have a flat pattern. So the final step would be to add these holes in here. And it's already been stated that we have 505, and then we have our angles, can be 28 and 143. So let's go back here, and on this top flange, let's grab this and we'll activate a 2D sketch, and we'll just draw in some reference lines. And we'll make them all the same length. And we'll get some angles here. This is going to be 28. And then we'll make sure it's centered here. We're at 14. And the other one was what? 143. And this will be, to center this one will be A71 divided by 2. And again, our radius here is 505. So we come here, get a dimension, 505. Okay, so now we know where our holes are going to be. Come up here and we grab our regular polygon, 6 sides, and we're going to just sketch out a few. And one more here. Now let's take a look at, see, is there an issue for orientation? We have the points are along the axis of the center line. So we'll come back in here, and what we're going to do is do a coincident like that, and then like that. One more, and then these are all going to be the same size, so we'll put an equal constraint between all of the inscribed circles. That diameter is going to be, I'm going to check on this here, 8.313. And then we'll do a sheet metal cut and change our depth through all. Okay, that. And there's our part. And one last check for flat. Our flat pattern unfolds. Okay. Now there's one more, me out of sketch mode here. Now we have a notch to put in here. This notch is going to be 40 millimeters deep, and on this curve anyway, it is from end to end 186.5, so unfold it's going to be, say, 186, 187 by 40, and we'll see how that looks. So we'll do an unbend, and now I don't need to unbend everything here, so I'm going to have an unbend, not rebend, unbend. My fixed face is going to be this one, and then the bends are going to be, it's going to be kind of touchy here to grab these. Boy, oh boy, they're small bends to grab here. There's 1, 2, okay, come on, come on, come on. All right. Zoom in here a little tighter. Okay. These small bends are really touchy to get to, and one more, I think. Okay, let's see what happens here. Okay, now we can sketch on this face, get a rectangle. Dimension this here is going to be 40. And we'll make this top coincident there. And I'm going to make this centered up on the origin. Is that going to do it? Nope. When we were at what, 186.5. Okay, now let's see, can I get a center up here? No, we're not going to get that centered that way, so what we'll do is I'm going to come in here and draw a reference line, short right on each end, and then I'm going to constrain this from this node to this edge. On that side, and from this to the bend line, and then I'll make them both equal. There we go. And we'll sheet metal cut to thickness, and then we'll rebend, select all unbends, and there's our notch. Okay, so that gives us our part now that's formed in sheet metal with the right radius. It's got the holes in the right spot and tabs that are fairly close to centered on these flanges. So anyway, let me minimize our tree here, and that pretty much shows how to make a bump form part, and hope this long drawn out process doesn't make you shy away from using this technique if you need to have a large radius formed into sheet metal. So hope this helps, and we'll see you in the next video.